everyone. Today I'm going to explain the step to be followed during the design of rivet joint. Okay. So in order to design a rivet joint, I hope you already gone through this calculation. In this example, you have to draw a double riveted lap joint with zigzag riveting, and the thickness of plate is 16 mm. So from the thickness, you can calculate the diameter of rivet, which is 24 mm, and rivet head diameter would be 1.6 times of diameter. So it would be 38.4, and radius would be equal to 19.2. So rivet head height would be zero point 0.7 times of diameter, which is 17 mm. This is the rivet head. Okay, and this is a length of rivet, and length of rivet would be equal to the thickness would be equal to thickness of plate. So in this case, you can see there are two plates having thickness of 16 mm and 16 mm. So you have to design a rivet of 32 uh, 32 mm, which can be inserted in the hole in the plate. Okay, so we would start. So click on File, New, and Part Drawing as we are creating part drawing. So in this case, you have to select some plane. There are front plane, top plane, and right plane. So I have selected the front plane, and you can select plane as per your. But the so in this case, we have to draw a construction. We can construct this line. Okay. So after that, we have to take some arc, and you already know the parameter of arc are radius of curvature and arc length. Okay. So in this case, the radius of curvature is 19.2 and arc length is 17. 17 is so in order to define this type of arc, we uh, have to draw this arc. This is center point arc. Okay. So this is start point, and as you know, the radius is 19.2, and we have to draw in this way. Now we have to define the radius of this arc, which would be equal to 19.2 mm. So this is 19.2 mm. After that, we have to define the length of arc. In order to define the length of arc, what you have to do, you have to draw line. Okay. So this line is 19.2 and this line is also 19.2, and as you know, the uh, arc length is 17 mm. So in order to define arc of this length, we have to subtract 19.2 minus 17 mm, which would be 2.2. So we have to so 2.2. Remaining arc can be trimmed. These are the extended portion. We require only this much arc as length of 17. So we would trim the remaining entities. Okay. This is the remaining entity. This is extended entity. It's also extended. So I think our purpose has been solved. Now you can delete this. Okay. Now we should know about this distance. Okay. So this distance is equal to, as you know, the rivet head diameter is 38.4 and rivet diameter is 24. So this is 24 and this 38.4. So the remaining, uh, if you subtract 38.4 minus 24, the remaining distance would be 14.4. Means 7.2 in this direction and 7.2 in this direction. So we have to define a line of length 7.2. After that, we have to define the height of rivet. Okay. So in order to define the height, as I already told that it would be equal to the thickness. So thickness is 16, or this thickness is 16, so 32. So I would take 16 mm and remaining part would be mirror. So this is 16 mm. In order to mirror, we would construct a line. I hope you already know about the mirror command. If you don't know, you can see. Firstly, click on mirror entity, and the option will appear entity to mirror. So we have to select this entity, and by press control button, we can select the other entities also. Okay, now mirror about. So we have to mirror about this line. So the final drawing this. So 16 mm, 16 mm. Now length of this rivet is 32 mm, which is equal to the thickness of two plates. Okay. Now we can use the revolve command in order to create the rivet. So in order to use the revolve command, firstly we have to close this check. Now you can use revolve. This is the revolve command. Option is a bearing axis of revolution. So we will revolve about this axis, and you can see the design of rivet. This is all about the rivet. Now we will draw the plate. As you can see, plate having the thickness of 16 mm, and there are holes, and the diameter of holes is 24 mm, and the is the distance between two holes, which is equal to 72 mm. Okay, and you can see the margin is 36 mm. Okay, so we have to select the length which would accommodate both pitch as well as margin and extended length. The extended length should be there in order to accommodate or fit some application for the end user. So the steps are quite similar. You have to select some plane. So we have select the front plane, and we have to construct the rectangle. Okay, so we will choose the center rectangle, and the rectangle having the dimensions 152 and 187. So as I told, we have to choose the dimension which can accommodate the pitch as well as the margin. This dimension is 187, and as you know, the thickness of the plate is 16 mm. So we will use the extrude command to provide the thickness. So we will use the extrude command, So extrude command is 16. So we extruded to 16 mm. So again we will back to the front plane, and we will provide a construction line in order to put the holes. So in order to put the hole, firstly we have to decide the circle and their pitch. So this is construction line, and the dimension, we have to define the dimension of this construction line. There will be some extended portion as well as some margin. So the dimension is 108. So the distance of this construction. So after that, we all again have to draw some construction line. For this, we would not draw. We would use offset active. So we will use offset active distance of 43 mm reverse lines. So another construction line, and we have to put the holes. In order to put the hole, firstly we have to provide the circle. The diameter of circle would be equal to the diameter of hole. As you know, this is zigzag riveting. Firstly we will draw the circle and then define the dimension of the circle. So the dimension is 24 mm dia. This is 24 mm in 24 mm. Either you can also use the equal dimension constraint. So 24. So now we have to define the pitch. In order to define the pitch, the distance between center and center of first hole and center of second hole would be 72 mm, and distance of first hole to the bottom edge to bottom is 58 mm. As I told, there is pitch of 72 mm. Is this distance 22 mm, and we will provide the pitch of 72 mm. So this is all about the circle. Now we have to put the hole. In order to put the hole, we have to put the blind hole in order to fit the rivet. We will use the extrude cut command. So click on extrude cut, and we can use the command of blind. As you can see, there are 4 blind holes. This, sorry, through holes, not blind. These are through holes in order to insert the rivet. So this is all about the construction. After modeling the rivet and plates, we have to assemble. For that, you have to save this rivet, and also you have to save the plate. Now we have to assemble rivet and plate. So click on new, we have to click on assembly. We have to insert the component, or sometimes So in this case, you have firstly you have to and now you have to insert the second plate. This is second plate. You have to rotate this plate according to first plate. For that, this way, in this way, you can see the extended portion of both rivet is in outside. After that, you have to use the mate command. Okay, so insert mate. Mate command we have to do coincident bottom of this edge. Coincident. After that, we have to insert the rivet. So this is the rivet. Firstly, we have to concenter the hole and have to use the after that we have to coincident the surface and edge. Coincident this face and this edge. So this is first rivet. So in order to another rivet, again we have to repeat that command. So we have rivet. Again we have to do the consent and then coincident, coincidentally this face again coincident this surface and this edge of the hole. Okay. Similarly, same procedure will be follow for other components. We will follow for next we will insert component. First is concentric one, this and this should be concentric and then coincident. space and edge of the hole. Okay. Similar step opted for last trick. Third component can also rotate as per your concentric. After that, we have to use coincident of this phase and this edge. So this is all about it. So in order to see the isometer, this is isometer of the repeater, and you can see other views from this view orientation. This is all about the assembly. So after completing the assembly, you have to save this assembly in order to import for drawing. So then click on File, New, and Drawing. Okay. So here you can choose the size of drawing sheet. So in this case, I have choose A4. So you can browse this assembly. This is top view. This is front view, and this is isometric. Okay. So three views are created in this drawing sheet, and it is appearing like this example problem. So here you can show the hatching line. Hatching line can be shown by the option annotation and then hatching. Okay. These are the hatching. After that, there is a center line. So we can also show the center line. So these are center line. Okay. And accordingly, you can also modify the weight of these center line. Here you can also put the And you can also show the dimension. Here you can see there are dimensions, so you can show the dimensions. So in order to show the dimensions, you can use the smart dimensions tool. Okay. Likewise, you can do the dimension for the all component, and this is final drawing. You can this look like this segment. Okay. And it this drawing is done in first angle projection in India. First angle projection